Problem 9.48. We're going to introduce a couple of new ideas, and that is how we address the difference between fixed and variable overhead, which is in general a little bit difficult for actually almost everybody. Actually, the variable overhead is pretty simple, but the way we address the fixed overhead and how to do the allocation, remember, we're not talking about the POR that we did in Chapter 7, but the actual allocation to the service department is a mental trick that stumps everybody. Okay, so this is going to take quite a bit of focus because the logic is different from what you're used to, and it is a good logic. So this is definitely, I think, like the way we should do it. When you first encounter it, though, you're going to stumble. So let's take a look then at problem 9.48. We'll take a look at the variable overhead allocation first, which will be the more direct one. Then when we do the second half of the problem, looking at the fixed overhead allocation, I'll stop for a minute and talk a little bit about the nature of why we approach it in that way. First thing is problem 9.48. We have the data. You can see you need to have this in front of you as we work the problem. We have notice it's a fairly simple setup, and in fact, the problem's simple. It's basically just a very, very small amount of computations. But what's really hard is the mental trick of knowing what to do. Okay, so when you look at this problem, and also if you were to look at the answer immediately, it just looks totally trivial and easy. Trust me, it is not. Okay, because the part that's hard is not the arithmetic or the complexity. It's actually not a very complex setup, especially after the last problems we've done. But the ideas are really sophisticated, and we need to focus on those. So this is what we have. We have one company that has 4 operating subsidiaries and an electricity generation subsidiary. So that column in there that says electric costs, that is they have a subsidiary that generates electricity. They have their own generator. Like Brock. Brock generates most of its own electricity, and now it generates it through hydropower, through water power. We have our own dam. It's on campus, and some of you may have seen it. If you run, there's a nice little running loop around the campus. If you take a run there, you'll see the dam. And we generate. Well, actually, I don't know if we generate most of our electricity now. When I first got here, we generated most of it, but our electricity needs have skyrocketed. So it could be that we are only doing part of our needs at this point. But that costs money. It's a whole, there are people who work out there. That's their job. There's equipment that needs to be maintained and replaced. It's hydropower, so all the lines, the path. I don't even know what you call it because it's not my business. But the water channels leading up to the dam, we have to keep those clean and not have them clogged. And we have to make sure the water going into the generator is actually clean, does not have a lot of particulate matter. So I'm sure, I've never done this, but I'm sure there must be some filters and some cleaning of the waterway, maintenance and stuff. So it's even, when you generate your own electricity, it still costs you money. So what we have here is we're generating electricity. It costs us 2 different amounts of money. Notice that there's a variable cost and a fixed cost. Okay, what you see is that the variable cost is $6,000. Look down, not the bottom line, but the next line up. You'll see that the fixed cost is $9,000. So that fixed cost is probably, basically depreciation or some annual charges like that. The variable cost would be consumables and potentially labor. So now we have to look at allocating both of those. We do it separately. We never allocate variable and fixed overhead in one schedule. It's 2 different thinking processes, 2 different schedules. So that other problem that we just did, problem 9.3, where that was the opening problem where we did the direct step and reciprocal method. If we were going to do that based on fixed and variable costs, it would be 2 schedules, not 1. Okay, if we're doing 1 schedule, that means we're doing TOH-POR, total overhead, predetermined overhead rate. And that's, so we're doing it on 1 schedule. If we are going to have variable and fixed costs, which is more normal for real businesses, doing the TOH-POR is, you do see it out there, but in this book, it's mainly a learning device. We need two schedules, one to allocate the variable costs and one to allocate the fixed costs. So we need to look at that. Notice in here you're not even given a lot of information. They do tell you electricity is carried over power lines to the branch stations, and they ask you to do the information below, using the information below in the step method. So we're going to use the step method. And then after we allocate and get the costs for each department, then we're going to compute PORs based on direct labor hours. Notice we'll have two different PORs, an FOH POR and a VOH POR. Let's do the variable cost first. Okay? So here we have the basic setup. Okay. We have service department and our 4 operating departments. Let me move that a little bit up here. So our 4 departments are here, and we have, these are all dollars. That was a mistake on my part. Okay. And what we have to do is take the service department cost and move it over. We have to transfer it. The same idea. So that schedule is going to look the same. It's going to have the brackets indicating a credit entry, and then the whole numbers, meaning the even numbers, indicating that they are debit entries to transfer into these 4 departments. So the first thing we have to do is transfer out the 6,000. Okay, that is going to, and we only have one variable cost, so when we do that, this will be 0. So I'm cheating a little bit, I'm going fast. We know we have to transfer that out. And you can sort of do that without doing any computations, once you've done this, because this, we have to end up like this, because we have to come up with that credit journal entry and transfer that out. The question is, how do we transfer it in? Okay. 2 different ways to do it, 2 different computations. The way is the same, but there are 2 different computations you can do. Given the information you have, you can either compute a dollar per kilowatt hour. Is that what we're doing, kilowatt hours? Dollar per kilowatt hour, or you can do the same relative proportion that we did in the last problem. Both work just fine, okay? If we look at the data that we have, if you scan across the data, you'll see that we have an amount of electricity used by each one of those branch offices. And if you look, it's 8,000 kilowatt hours, 9,000 kilowatt hours, 7,000 kilowatt hours, and 6,000 kilowatt hours. If we convert those to proportions, we will add them up, and we will get actually a total of 30,000 kilowatt hours, which notice is actually what we have under the variable cost column for the electricity generated. That's because for the variable cost, the amount of electricity we produce is equal to the amount that they use. I mean, in a technical way, maybe there is a little bit of line loss, but the assumption is, based on our measurement skill level, that what we generate is what is actually used. And so you can either add that up to get the 30, or notice, that 30,000 has to be total usage. And then you convert each of those into a percentage. So 8,000, you can see 8,000 divided by 8,000 kilowatt hours divided by 30,000 kilowatt hours. Notice, I always tell you to put units on things. The book doesn't always do it. Notice in this problem that actually not having the units on the numbers can get your brain a little bit scrambled sometimes. So 8 over 30 would be about 0.266, something like that. That would be about 26% of the $6,000. Or if you figured out $1 per kilowatt hour charge, that would be $6,000 divided by 30,000. That would be $2 per kilowatt hour. Multiply that by the 9,000 kilowatt hours, and then guess what? The answer is going to be the same. So what we end up with is $1,600 being transferred in to this unit. Okay? And we can either take the decimal fraction, I'll do this here, the 8,000 kilowatt hours divided by 30,000 equals 0.2666, okay? And take 0.2666 times 6,000, and you're going to get 1,600. Or you can take 6,000 divided by 30,000 kilowatt hours equals $2 per kilowatt hour, okay, times, I'm pointing to something that's not there, times the 8,000 kilowatt hours that the Rockford division used, from your data. So 2 times 8,000 would be, or actually that's not 2, it's 0.2. 0.2 times 8,000 would be 1,600. So the logic is the same. You can either do proportional, the decimal fractions, or you can actually compute $1 per kilowatt hour in this case. When you do that for each one of these, you will get $1,800 here, 1,400 and 1,200. So this is the step method, but actually, because there's only one transfer, it's the same as the direct method. Okay. So obviously, this is a simple problem. They're trying to get you to focus on the difference between the variable and the fixed cost. We can add these up: 26,600, 31,800, 21,400, and 16,200. Okay. Now the last part of the problem said we need to figure out the POR, because these costs now, this is the total overhead cost in each of those 4 departments. There's no more overhead in that service department, but we have those total overhead costs in those departments, and we need to figure out the POR. Every one of these departments is going to have a hugely different POR because they use a different amount of direct labor. So if we look back at the data that you have, so look at that, or you can pause the video and take a quick look back. You'll see that Rockford has 266,000 hours of direct labor. Peoria has 3,180 hours of direct labor. Hammond has 107,000 hours of direct labor. And Kankakee has 8,100 hours in direct labor hour. So what we'll do is take each of these numbers and divide it by the by the direct labor hours associated with that organization. So this one, let me erase a couple of things here. I have an erasing tool here somewhere. So this is the total, financial total. What we want to do is basically have the second part of the problem. So the B part of that's the A part of the problem. The B part of the problem is to take this number, $26600 divided by 266. Let me make sure I'm doing this right. 266,000 DLH, and that's going to leave me with 0.1 or 10 cents per direct labor hour. So $0.1 per direct labor hour in Rockford. I'm not going to do the detailed computations here, but I'll give you the answer. Okay. So notice that these 3 organizations have a gigantically different charge rate based on what they do. So this unit has a huge amount of direct labor hours, so some sort of manual process. The other one with a huge amount of direct labor hours was Hammond, so some manual process. But these 2 units have very few direct labor hours. So we're talking, mainly some sort of automated production. How many people? Let's see. Peoria was 3,180 direct labor hours. That's like 2 people, right? Because we work, as a rule of thumb, 2,000 hours. Now, don't use that. Remember how we have some of these rules that we use, like we pay for 8 hours, we get 7.5 hours, how many work days and about that. This one is a little bit looser than that rule, but people work about 2,000 hours a year. In fact, it's a little bit less in the OECD countries, meaning the European countries and North America. And it's a little bit more in other places. Okay, Switzerland is actually probably 2,200 hours. So in Switzerland, they work more than we do. They work probably an extra 4 hours a week than we do. Even though we think of them as more developed, they actually, their minimum work week is, I think it's 4 hours longer. And they had a national referendum, it was about 5 years ago, to reduce that to 40 hours a week, and it failed. So their culture is definitely a hardworking culture. But basically, as a rule of thumb, when you're looking at things and having a few discussions, assume 2,000 direct labor hours is what one full-time worker works a year. And so that would be that Peoria has basically, 1.5 full-time people, and Kankakee has basically 4 full-time people. So, pretty small operations and pretty or highly automated production. And notice that they have these really big charge rates. And the two organizations that have a lot of people working have these really low charge rates. So that's one feature of automated production and variable cost. Okay, so that's step A in this problem, which is to do the VOH. So this is all, I'm ashamed of myself. I usually write this on the board, to sink the memory deep into people's brains. And this is the VOHPOR, variable overhead, predetermined overhead rate. Okay, because this is all variable overhead. It's not total overhead. Okay, let's flip this around. Let's take a look at, for a second, at the other data that we have. And if you look over there, what you'll see is we have something else that we've not really talked about before, and it's a bit goofy, and this is where the struggle comes in, is recognizing that this makes sense. It's actually fairly hard, and that is, it's usually pretty obvious to us what to do with a variable cost. Remember, these are all budgeted, right? These are budgeted numbers. That's pretty easy for us to think about because we can imagine it. But when it comes to fixed cost, we have a hard time figuring out how to allocate fixed cost. Like, what's a reasonable way to do this? Look at the data we have, and you have that thing that says capacity usage. Okay, that it's hard to interpret what that means. It means the maximum production, or this is the production that we purchased. This is what's available to us. And notice that the equipment we have can produce up to 50,000 kilowatt hours per year. And if you look up there, we only produce 30,000. So we can produce more than we are producing now, which will always be the case. Everything we buy is always too big. There's no real exceptions to that, right? I mean, just think, we always buy cars that can fit more people than we usually put in them. We buy photocopiers or printers that print more than we're going to print on them, right? How many times did you actually have a printer, a laser printer, actually die from overuse? No, they just get old and we throw them away. And when we throw them away, they're still working fine. Why? Because we paid for a lot of capacity that we didn't use. And you have to do that. Everything we do, we pay for extra capacity. And, we sort of know that, but not explicitly. Okay? And it's, there's even jokes in some parts of our economy about certain aspects of this. So they talk about the police being at the donut shop and hanging around and doing nothing. And that's true. Police spend a lot of time doing nothing, just, and they get paid a lot of money. And, they often do nothing all day. And the truth is that's fine, right? Because, in fact, we like it better when they do nothing, because that means, all hell's not breaking loose. And so when you have a problem, you need somebody to come and fix it then. So you actually, when you call 911, there has to be a police officer sitting in a donut shop somewhere, or no one can come to you, right? The only way a police can come to somebody is if they're not doing anything when they get called. Same with the fire department. So we actually, we don't talk about it like that because we don't like to, but almost everything that we have in our government, our society, our home, our house, at Brock, is a huge overbuy of technically what's needed. But we know that there are always fluctuations in what happens. And we know that when we call 911, we really want a police officer to come, or we want an ambulance to come, or we want a fire department to come. The only way that can happen is if those guys are not doing anything when we call. So that means we have to buy more. Okay? When you come to Brock and walk down the hall to Terrell Hall, you want to be able to walk down the hall to Terrell Hall. Guess what? The only reason you can do that is because there's nobody in the space that you need to be in. Okay? There might be somebody ahead of you, but the space you need to be in, you're the only one in there, and no one's pushing you to get you out of there. Even when it's busy out there, there's still extra space in Terrell Hall because we have to have that. Okay? So this is a tough question. Actually, it's pretty philosophical, and most people never really deal with it. And this is one of the political fights. You know, the right-wing guys complain about certain things, and the left-wing guys complain about certain things. And this is one thing that neither one of them understands, you know. And sometimes they're on the same side of the issue and they don't know it. But basically what we have is, government waste. What is government waste? Well, look, it's not actually that clear what government waste is, because if you cut out all the waste, then no one will come when you call 911, or no one will pick up the phone, because that's also the same thing. If you call the city government or a business and someone picks up the phone, the only reason they can pick up the phone is because they weren't doing anything when you called. Okay? This is a giant paradox. Okay? Is that we have to create slack capacity. So when we're looking at this, it sort of bubbles up here, because we say, okay, we have these 4 divisions: Rockford, Peoria, Hammond, and Kankakee, and we have $9,000 in fixed costs. How can we charge this out to them? And if we use the logic of fixed and variable costs, one of the first things we'll say is it's not appropriate to charge it out based on the variable cost ratio. We should charge it out based on something else, but what? And the answer, sometimes in class I spend some time talking about this, or actually I ask you guys a bunch of questions. But basically what we are going to go by is we're going to charge fixed cost out based on capacity. Okay? And that's why we have that word there, capacity cost. So if you look at Rockford, Peoria, Hammond, and Kankakee, each of them has listed a capacity. It's 10,000, 20,000, 12,000, and 8,000, which you can see. Okay? So if we add that up, which I haven't done, but I'll do it in my head now, 30, 42, 50. Oh, it's 50. Actually, that is a bit unusual. That's not realistic. Often, if you add up the maximum demand, or the maximum demand that each branch could ask for, it would actually be greater than the capacity, the fixed capacity. In a realistic case, in a realistic sense, they would be greater. But what we're going to use to do this allocation is actually that 50,000 maximum capacity, and we're going to allocate the $9,000 cost to each of those branches based on the maximum capacity that they could use. And the logic we're using is to say they need to contribute to the capacity that they can call on later. Because if we don't have the extra capacity, it won't be there when they need it. So they basically need to buy some of this unused resource. And that makes that resource available to them if business goes up, and if they expand, then it's available to them. And so they're paying for capacity or availability. This turns out to be a giant stumbling block for almost everybody. So given that data, it's the same problem, and it's going to be just as easy. So, in the setup sense and the arithmetic sense, this is one of the easiest problems we'll do. So we have the service department, we have Rockford, Peoria, Hammond, Kankakee. These are all really famous cities in the US. They're little towns, but in the 1920s and 30s, they were on the vaudeville circuit. And so for people on the East Coast, there were a lot of songs and stories about these towns, especially Peoria and Kankakee. Rockford a little bit less, Hammond a little bit less. So even though they're sort of oddball names, At one time, they were really well known because of some of the songs about them. And then in certain parts of the music industry, those names continued on. So actually, a lot of Americans know them. They don't know where they are. But there's even a saying that won't play in Peoria, because Peoria was famous for being very socially conservative. So the vaudeville acts and all the other players had to tone down their language to a very conservative level before they went to Peoria with their shows. So the expression is that won't play in Peoria. So, you know, just another tidbit. So we need to get the costs up here and then do the same sort of difference here. So we have, this was the $9,000, $13,000, or $130,000, 145, 90, and 150. Now, take a look at this. One thing you'll notice in this problem, and this is totally realistic, notice that the fixed costs are way bigger than the variable costs. In my life experience, this is actually closer to reality. Variable costs they're really not that big in a lot of places. It's the fixed costs that are the really big ones. And we're going to do the same thing. We're going to do our credit entry here, the $9,000, which will get us to the 0, which is where we want to be. I forgot to mention on the other side, that whole row across here is a journal entry. You have to actually put that in the general journal to transfer this from one department to the next. And then we're going to actually do the transfer of the money. $9,000 we can do it the exact same way we did before, at proportional or $1 per direct labor, or $1 per kilowatt hour. Either one will work. Remember, we have $50,000 as 50,000 kilowatt hours as the denominator. And for the numerator, for Rockford, we have $10,000. So, did I put the wrong thing? Oh no, that was kilowatt hours too. I was mingling those two solutions. So what we have is 10,000 kilowatt hours. So we're going to have, 1/5. We'll have 1 over 5, or 0.2 is the proportion that we'll have. So 0.2 times 9,000 is going to be $1,800. And we'll recompute a new fraction for each one of these based on the kilowatt hours, and we'll end up with $3,600, $2,160, and $1,440. Adding that, 131.8, 148.6, 92.160, and 150.1440. Okay, what is this? This is the total fixed overhead in each of the 4 departments. There's no overhead left here. It's been transferred out. So now the last part of the problem was to do the FOH POR, which we do based on direct labor hours. Once again, I'm just going to do the first department. And so if we look at direct labor hours in the first department, it was 266. And $131. That's going to give us, of course, dollars per DLH. And we'll end up with 0.5. Okay. And unfortunately, I didn't line this up. So for Rockford, it's 50 cents, or $0.5 per DLH is the FOH POR. So in this problem here, we've actually done the Chapter 9 step, and we did the Chapter 7 step. So this is the Chapter 9 portion, which is the allocation. This is figuring out the number for the Chapter 5 and 7, which is the application. So this is the application rate. The POR is the application rate to apply the overhead to the product. based on direct labor hours. I'm not going to do the other three. I sort of modeled this one. You can figure that out. Also, you have the solutions manual. You can also do the TOH POR by adding these together, because if, you know, the variable and fixed, if you add them together, it'll be the same. So this is 0.5, and from the other page, you would have remembered, or you can go back and look, it's $0.1 per DLH is the FVOH POR. If you add them together, it'll be $0.6 per DLH is the TOH POR, total overhead, predetermined overhead rate. Okay, so you can add them together. So 9.48 looks, you know, actually when you look at it, it's one of the simplest problems you will do based on the layout and the numbers. But actually, when you approach this, because of the different thinking process, most people will find this to be fairly difficult. And similarly, in some of the other problems, like in 9.49 or other problems when you're doing the variable and fixed overhead rate, they are a challenge, in particular the fixed overhead rate. Figuring out what to use as the charge vehicle, like, you know, how are you going to charge them out? And sometimes in the book and on an exam, you're going to have to read the text and say, well, what was budgeted here? What was our original plan? And what original commitment did we have to make? And so that's another way to think about this, is when we originally built this resource or acquired it, we had to do some planning. And based on what these four divisions wanted, we made this as the commitment. So I don't really have it written down here, but remember, part of this is this is the fixed cost for doing 50,000 kilowatt hours of electricity. So we made a commitment to have the capacity to do 50,000 kilowatt hours. Okay? And that is what we're paying for here. And each one of these, we made a commitment to each one of these groups for an amount that we would give them. So in effect, another way to think about it is with fixed overhead, we will allocate based on our commitment, not on actual usage, but on the amount of the commitment. Because we'll say this cost, we incurred this cost, not because of usage or making of electricity. We incurred this cost because of the commitment to be able to make the electricity. Okay? So that then is the end of chapter 9. Or, you know, it's not the end of chapter 9, but that's the last problem I'll be going over in chapter 9, problem 9.48. And you should review it, and as always, and look at some of the other problems that have fixed and variable overhead computations in them. And we will move into chapter 10, activity-based costing, next week. Bye-bye.